equipment chapter number 6, measurement of resistance. Okay, measurement of resistance. When we are talking about resistance, how could we measure this resistance? For measuring this resistance, we should know what value to be measured, right? What value to be measured. So we have to divide this resistance in some ranges so that we can properly measure those resistance. Like we can divide this resistance as number 1 low resistance, number 2 medium resistance, and number 3 high resistance. Okay, what are these low resistance? Basically this low resistance, the range is coming below 1. If the resistance value is below 1 ohm, we treat it as a low resistance. And for medium resistance, when the resistance value is in between 1 ohm to 100 kilo ohm, it is treated as medium resistance. And for high resistance, when the resistance value is greater than, when it is greater than this 100 kilo ohm, then we can consider this at high resistance. So basically, we can divide this resistance into 3 types. First type is the low resistance, which value is less than 1 ohm. Number 2, medium resistance, which value is in between 1 ohm to 100 kilo ohm. And the third is the high resistance, which value is more than 100 kilo ohm. Those resistance are called as high resistance. So what are the processes? Basically we are going to measure this resistance, so we should know the processes. So for measuring this low resistance, we are going for potentiometer method. We are going for this potentiometer method. So we know this potentiometer are very sensitive device. So they are used for measuring this low resistance. And for medium resistance, we are going for bridge method, that is Wheatstone bridge. Wheatstone bridge method. And number 3rd, for high resistance, basically this high resistance we call it as insulator, because we are having very high resistance. So some special method should be there to measure this high resistance. There are other methods, but we are seeing here loss of charge method. We are going to see here loss of charge method. Loss of charge. So we will see this 3 types. One is potentiometer method, second is Wheatstone bridge method, and third is loss of charge method. So first we are going for the measurement of low resistance. So we are going for the measurement of low resistance. Measurement of low resistance by potentiometer. Method. Potentiometer method. Measurement of low resistance by potentiometer method. So what is here? We are taking a supply. And a rheostat is connected it is rheostat is connected with the resistance. There are two values. One, let's call it R, one it is called as S. So basically here there is a switch and this switch is connected with the potentiometer. This switch is connected with the potentiometer. And here we can connect a ammeter. Here we can connect a ammeter, right? Here we can connect a ammeter to measure the value of current. Here we can measure the value of current with the help of ammeter. So this is our circuit diagram. Here is a DC supply, voltage source, DC supply. We are connecting with a rheostat and with an ammeter and with two resistance, that is R and S. Let's say that one resistance like S, we are calling it as a standard resistance. It is calling it as a standard resistance. And R is the unknown resistance. R is the unknown resistance. So what we are doing in this method, when we are supplying, when we are giving supply with a voltage source, then there is a switch connected with the resistance R. So basically this switch is called as double throw switch. This switch is called as double throw switch. Double throw switch. So basically in first instance we are connecting the switch with S and in second instance we are connecting it with R. So when in first condition, let's see the condition 1. Okay, when we are connecting the switch with S, then we are supplying this battery or voltage source. So by varying the rheostat, we can set the current by measuring it with the ammeter. By measuring it with the ammeter. So basically, when we are giving a voltage source, the current will flow. Basically, if voltage will develop, that voltage will be multiplied of current with that resistance. So in first condition, that voltage rate with across S, the voltage is coming Vs. Across S, the voltage is coming Vs. So when we are fixing the current by varying the rheostat, basically we can take that current, let's say we are denoting every time current with I. So basically this Vs will be I multiplied with S. Okay, simple formula. Vs will be I multiplied with S. So let's say this is equation 1. So we can find I, that will be equals to Vs by S. So major work is not to find out this, major work is for potentiometer. Because we are employing this potentiometer because it is a very sensitive device. The potentiometer, it can measure a very small change in voltages. So that's why we are employing this potentiometer. So by that we can find Vs, that will be multiply of I into S. So we can find I is equals to Vs by S. Let's say this is equation 2. So for condition 2, because we are going to measure this unknown resistance, so for condition 2, what is happening? So we are changing our pole. So we are changing our switch. The switch is again connected with S and I is remaining constant because we have fixed the I by varying the rheostat and the I is coming same. So basically in second condition, when we are going to measure the voltage across R, so basically we can say that the voltage it is coming there, it is VR is equals to I into R. So how we can find this voltage? We can find this voltage by potentiometer. How we can find this voltage by potentiometer? Because we tell that potentiometer is a very sensitive device. It can identify very small change in voltages. So we have find out VR that is equals to I into R. So let's say that this is equation 3, and here we can find I again similar. I is equals to VR by R. I is equals to VR by R. This is equation 4. When we are seeing the equation number 2 and 4, basically the current will be same in the circuit. So we can equalize these two equations, like from equation 2 and 4, from equation 2 and 4, we can write that Vs by S is equals to VR by R. So this is the equalizing factor where Vs by S is equals to VR by R. And what is the unknown resistance? R. So we can find R, that will be equals to VR into S divided by Vs. So we can find this unknown resistance because we have measured VR, we know the standard resistance S and the Vs, the voltage across the standard resistance. So we can find the unknown resistance when we know the parameter VR, Vs and S. So by this equation we can be going to find out the low resistance value.